In this video, we will learn about characteristics of a chemical equation. What does chemical equation tell us? Okay, the chemical equation provides both qualitative as well as quantitative details of the chemical change or chemical reaction. So the first thing which we can know from a chemical equation is chemical equation provides the names of various reactants and products of a chemical reaction. For example, we have a reaction H2 plus O2 gives H2O. So, just by looking at the reaction, we can say that this reaction involves hydrogen, oxygen. Okay. Second point, chemical equation gives us the number of atoms and or molecules of the reactants and the products of the chemical reaction. So if this reaction is balanced, if we balance this reaction, for example like this, we can know exactly how many atoms are involved in this reaction. So in this reaction, 2 atoms of hydrogen are involved, half of O2 are involved, or 1 atom of oxygen. Okay, so in this reaction, half of O2 are involved, or we can say only O is involved. Okay, 1 oxygen. Third point, it gives relative number of moles of the reactants and the products. Relative number, not the exact. It gives relative number of moles of the reactants and the products. So even if it's unbalanced, at least we can tell how many relative number of moles are on the reactant side and product side. It gives the relative amount of by mass of the reactants and the products. We can also calculate the mass. So the mass of hydrogen in this reaction, mass of hydrogen is 1. So mass of 2 hydrogens will be 2. So we have mass of hydrogen 2 involved in this reaction. The mass of oxygen is, for O2 it's 32, but we have only half of O2 involved in this reaction. So in this reaction, 16 mass of oxygen is involved. Okay. Now, coming to point 5, it also provides information about the relative volume of gaseous reactants and products. How does it provide information about the volume? You know that there's a relation that number of moles is directly proportional to volume. So, if more number of moles, then more is the volume. If less number of moles, so less is the volume. So this is how it provides a concept of volume as well. Now, let's take an example. Let's take this equation. Calcium carbonate dissociates. When we heat it, it gives calcium oxide and carbon dioxide. What we have, given the atomic mass of calcium, we know it's 40, carbon, we know it's 12, and 1 atom of oxygen, it's 16. The information provided by the equation can be summed up as follows. What can we extract from this equation? Let's see. First of all, the given equation tells us that when calcium carbonate is heated, it produces calcium oxide and carbon dioxide. We know that, okay, by looking at the equation. It does not provide anything else. It provides only calcium oxide and carbon dioxide. It does not make anything else. Second point, one molecule of calcium carbonate on heating gives one molecule of calcium oxide and one molecule of carbon dioxide. But for that, this equation has to be balanced. Okay? You cannot say this on an unbalanced equation. Third point, 1 mole of calcium carbonate decomposes to give 1 mole of calcium oxide and 1 mole of carbon dioxide. As you can see that in the previous there was molecule, and now we are saying mole. What is the difference between a molecule and a mole? Simply this, anything which is made up of elements, for example CO2, this is made of carbon and oxygen, we can call this entirely as a molecule. Okay, and if there are number of these present, for example 3 CO2, we call this 3 moles of CO2. Okay, so mole is a quantity we use for calculation and molecule is just for the definition. Okay, fourth point, 100 gram of calcium carbonate decomposes to give 56 gram of calcium oxide and 44 gram of CO2. How do we know that? Just by calculating the mass here. As you can see in the equation, we have CaO. How do we know how much mass of calcium oxide is produced? Just check the mass of 1 mole of CaO, that is calcium oxide. What is the mass of calcium? It's 40. So 40 plus what is the mass of oxygen with it? It's 16. 16. So this way it comes out to be 56. So 56 is the mass of CaO. So 56 grams of CaO are made out of this reaction. Similarly, the mass of carbon dioxide can be calculated. Then, the chemical equation does not tell us everything. So there are limitations. We don't know whether this reaction actually happens in the real life or not. Okay? It does not tell us whether this reaction actually happens or not. Some reactions happen only when we give them heat. Some reactions happen spontaneously. That means we don't have to do anything. They just happen themselves. Some reactions do not happen at all, even if we provide heat. So we can write any reaction, but we don't know if it actually happens in the real life or not. We can't tell that. The reaction is expected to take place, but actually it does not occur, this reaction. If you mix copper plus dilute sulfuric acid, we are expecting to get this, but it doesn't happen in the real life. Second point, second limitation, chemical equation of the reaction does not give any actual idea about the rate of reaction and how much time it will take for the completion of the reaction. That means we don't know how much time it will take for reactants to get converted to product. It will take, whether it will take 1 day, 1 minute, 1 second, 100 years, we don't know. If a substance is in the form of a solution, the chemical equation normally does not provide any information about its concentration. So if substances are in the form of solution, for example, we have substances in the form, for example, we are mixing two solutions, then we don't know what will be the concentration of both solutions in the product which will be formed. Okay? I hope this topic is clear to you.